Okay, I welcome all attendees back to the ICP DAS web seminar. This presentation is about ICP DAS EtherCAT solution. Thank you for showing interest into our EtherCAT series and taking the time attending this meeting. My name is Martin Kroschert, and my department at ICP DAS is responsible for the development of ICP DAS EtherCAT series. This presentation will first give a short introduction to the ICP EtherCAT protocol, its benefits and advantages in the automation industry. The main focus of this presentation is to give you an introduction into the ICP DAS protocol solution, and starting from the EtherCAT master and slave series, the diagnostic and configuration software, the application software programming tools, etc., needed to implement an EtherCAT-based motion control application. And at the end of the application, this seminar, a couple of EtherCAT motion control applications are shown, which are using our EtherCAT products. First, a quick introduction into the EtherCAT feature, its main key features, and why is it so appealing in the automation industry. What is EtherCAT? EtherCAT stands for Ethernet of Control Automation Technology. It is an industrial communication technology based on Ethernet, designed to be used in the automation. EtherCAT is one of the fastest and most popular industrial Ethernet products, especially for the PC automation, and it has been growing at a fast rate. The main reason is that it addresses some specific concerns for the industrial automation, such as fast communication with rapid response time, short cycle times, at highest transmission rates, and extremely low latency. EtherCAT is a real-time Ethernet field bus. It provides deterministic and accurate synchronized data transmission, which classic field bus systems cannot realize. So EtherCAT is optimized for precision machine control. Its high data load and efficient data transmission reduces the data traffic on the network and prevents data collision and ensures short cycle time. It is a flexible network which supports all types of topologies. This is a cost-efficient network with low cost of implementation. EtherCAT is developed as an open standard. The protocol is now supported by dozens of vendors of server drives, remote I/O blocks, actuation, and sensing devices. What is EtherCAT? Why is EtherCAT so fast? What mechanism does EtherCAT use to achieve such a high communication speed? EtherCAT utilizes a processing on the fly approach for transporting data packages throughout each slave in the network. The main feature of this mechanism is data exchange between the EtherCAT telegram and slave is completely done in hardware. So data extraction and insertion between frame and slave is done purely by hardware only. Another feature is data exchange takes place at full frame speed. Processed data is extracted and inserted into the frame while the frame passes through the slave at full speed. The data exchange between slave and frame is completed before the frame moves to the next slave. Another feature of this mechanism is that the slave does not read the entire EtherCAT frame, but only part of the frame assigned to it during the configuration process. The unique features of the processing on the fly mechanism makes EtherCAT communication so fast. EtherCAT is optimized for reduced data traffic. Traditional EtherCAT network consists of a master controller along with multiple slave devices connected to the master using an Ethernet cable. Typically, only one EtherCAT frame per cycle is needed to exchange data with all the slaves in the entire network. Each cycle, a single telegram is passed by the EtherCAT master with the data of all nodes. The telegram is passed around a ring where each node exchange data with the telegram and returns back to the master with the last slave receives the telegram, which means in each cycle with just one frame, each slave is updated with new output data from the master, and the master receives new input data from all slaves. So the low data traffic enables extreme short cycle time for the EtherCAT network. In addition, cycle time is fixed. How many slaves are on the network. EtherCAT slave uses the distributed clock mechanism to ensure a deterministic and synchronized behavior of all the slaves in the network. Each slave is equipped with a separate clock which has this is precise synchronized across the EtherCAT network. The distributed clock mechanism ensures that all slaves read input data and writes output data across the slaves synchronously. This ensures that all the input data, such as digital signal, sensor values, and motor position measurement are all captured at the same time. In addition, all the output data, such as actuator value and commanded motor position values, are outputted synchronously. So exact synchronization is particularly important for precise machine control. For example, this is the case for application in which multiple server execute coordinate motion movements. EtherCAT is virtually limitless when it comes to network topology. Line, tree, star, ring topology, and any combination thereof are supported. Advantage of the flexible topology is existing automation machines and equipment can be easily and flexibly extended. In an EtherCAT application, the machine setup determines the network topology and not the other way around. So any topology can be chosen to flexibly adjust the network to meet the machine's applications requirement. Moreover, thousands of devices can be connected to an EtherCAT without the use of external switches, which reduces the cost and avoids restrictions when designing a network. EtherCAT network setup and configuration is simple. EtherCAT devices are easy to configure and put into use. No addressing needed. EtherCAT itself is based on the processing on the fly mechanism and is not based on TCP/IP. Therefore, no need to administer MAC addresses or IP addresses. EtherCAT master can be set to automatically assign each slave with a unique address, which eliminates the need for manual address setting. EtherCAT is a simple and robust network infrastructure. No external switches are required. Uses standard Ethernet components to keep the implementation costs low, supports cable redundancy, and no network tuning required. It's easy to maintain. It's outstanding diagnostic features, simplifies the maintenance and network troubleshooting. In summary, simple configuration, outstanding diagnostic features, and low maintenance effort are all factors that contribute to a low system cost. ICP thus integrates the unique features such as high transmission rate, real-time behavior, distributed clock mechanism into our programmable automation controller series to provide the customer with a cost-effective, compact, and high-performance EtherCAT automation controller. ICP thus provides a complete EtherCAT solution. ICP provides a full range of product components for the EtherCAT network from master to slave. Our EtherCAT products are all developed and manufactured in-house. Both hardware, software, including firmware, are all developed in-house. This has mainly two benefits for our customers. First, our strict quality control ensures a consistent high product quality, which provides the customer with a reliable product. And we can flexible and in short period of time adapt our EtherCAT products to an application-specific requirement of a customer. Now to our EtherCAT master solution. ICP has three types of EtherCAT master in its portfolio. EtherCAT master type has an integrated, real-time, high-performance motion engine that can synchronously control multiple server access. The EtherCAT master types are the PC-based motion controller ECAT M801 series, programmable automation controller the EMP9000, and the EMP2000 series is a palm-sized controller, very compact motion controller. All masters are deterministic, fast, precise, and support a cycle time of up to 0.5 milliseconds. All EtherCAT operation modes are supported, such as DC, pre-run, and sync mode. Depending on the controller type, up to 512 nodes are supported, and up to 64 server access can be controlled in the EtherCAT network. ICP masters all support third-party EtherCAT slaves, which makes it very flexible as an EtherCAT network can be constructed with ICP EtherCAT slaves and is, if necessary, with slaves from other vendors. Many EtherCAT masters on the market only support slaves provided by the same vendor as a master and does not support slaves from other companies. An EtherCAT network constructed by the master from ICP can be flexibly extended with slaves from all vendors. ECAT, this is our ECAT M01, is our ICP-based EtherCAT master solution. It is a PCI card required with a high-speed real-time OS and a real-time EtherCAT master in a powerful multi-axis motion engine. It converts any standard industrial PC with a PCI slot into an EtherCAT master and a real-time motion controller. Its main features is it achieves a fast time of 0.5 milliseconds. It supports up to 500 slaves in an EtherCAT network. It is deterministic and accurate, controls up to 64 actions synchronously. The slaves with CIA 402 profiles are automatically detected and configured by the EtherCAT master to simplify the integration. The motion engine generates several types of motion profiles, including point-to-point, linear, and circular interpolation and contouring. The product comes with an extensive software package such as software utility and workbench for configuring and testing and diagnosing the EtherCAT network. All libraries for motion control execution and for direct exchange data with remote sales are available. The libraries can be linked to any standard programming language. Our EMP9000 series is ICP-DUF's EtherCAT-based programmable automation controller with main focus on motion control applications. The device comes with a pre-installed Windows IoT operation system. The built-in motion engine, together with the EtherCAT master, are running on a dedicated processor in a real-time environment to achieve a time-deterministic control of the EtherCAT application. The multi-axis motion control kernel controls up to 32 axes. The stepper and server jars, which meets CIA profiles specification, are automatically detected by the motion engine and can be put into operation without tedious configuration. Motion commands for single-axis and multi-axis synchronous coordinated movements like linear and circular and helical interpolation, all part of the library. The EtherCAT master and motion control features of the EMP9000 series are both very similar to the PCI card ECAT M801, as I already just introduced, because both are implemented in a similar way. This means the configuration and diagnostic tools are the same, identical libraries, and programming on the EMP9000 is very similar to the standard Windows-based programming. In addition to ECAT and motion control support, the EMP9000 series has several features that makes it an ideal partner for the industrial automation application. Its robust design uses a 3U rack mount metal chassis. Its full metal housing reduces noise interferences. They support a fast and large memory and CPU. Its fast CPU or large memory supports a Windows-based application. PC-based Windows application already developed by the customer can be directly installed on the EMP9000. Multiple Windows applications can run at the same time, similar to a PC-based system, HMI, logic, machine control application, and additional vision processing system, data gathering and processing application all run simultaneously on the EMP9000 platform. It is equipped with a variety of communication interfaces, such as serial, Ethernet, and USB ports, which allows the controller not just to access the EtherCAT network, but also other EtherCAT networks, such as Modbus, can open even, or exchange data with the cloud. Its outstanding features is flexibility and expandability. The EMP series are very flexible and can be adapted to your needs. Expansion slots are provided for local IOs and communication interfaces expansion. ICP provides a wide variety of digital and analog IO plug-in modules for the local expansion slots, as well as communication interfaces such as serial and Ethernet and USB ports. Fast USB 3R plug-in for camera and vision control are available. In addition, the memory can be increased by plugging in a memory card into the CF card slot. In summary, the flexibility and robustness of the EMP9000, together with the time deterministic and high precision of the EtherCAT-based motion engine and Industry 4.0 capabilities such as machine-to-machine communication and Internet of Things, makes it an ideal partner for the machine automation industry. The EMP 2000 series is a compact PLC with a real-time EtherCAT master and PLC open defined single-axis motion control functions. The EMP 2000 is ICB-DA's entry-level motion controller, which controls up to 128 slaves and 16 axes. The integrated motion functions are limited mainly to a single-axis control. It supports server and stepper drives with the CIO profiles, and programming has to be done via ICB-DA's PLC workbench called Win-GRAF. The EMP 2000 is an ideal solution for small and medium-sized automation applications in those areas that are limited by space, and for applications which just require simple point-to-point axis movement. The device comes with a built-in web server. EtherCAT network configuration and diagnosis have to be done via a standard web browser. Single-axis motion control, parameter setting, and testing can be done via a web browser. In addition, the motion path, velocity, and other parameters are shown in an XY graph. The table compares the key features of our EtherCAT master types. The ECAT M801 and EMP 9000 are similar EtherCAT-based motion controller. Commands such as single axis, circular, and helical interpolation motion commands are supported. Application can be written in any standard programming language. The main difference between both controllers is the ECAT M801 runs on Windows and Linux and can control a larger number of axes. In addition, a SoftPLC runtime with an integrated OPC UA server is available for both the ECAT M01 and the EMP 9000 controllers, which converts the industrial PC or a PLC pack controller into a standard PLC controller. The EMP 2000 series, on the other hand, is a pure PLC controller, which application program has to be written in one of the PLC-defined languages, and currently it does not support OPC UA server. Only single or multi-axis point-to-point movements are implemented, and all motion libraries are defined according to PLC open specification. So all our EtherCAT masters allows the integration of third-party EtherCAT slaves. Now to our EtherCAT slave solutions. ICB-DAS provides a wide range of EtherCAT slaves. The product portfolio includes a large variety of digital and analog I/O modules, as well as converters, gateways, motion control modules, etc. An entire EtherCAT network can be constructed just by using ICB-DAS slaves. And ICB-DAS slaves are all passes the EtherCAT conformance test and have been verified for interoperability with third-party EtherCAT masters, such as TwinCAT, Acontis, etc. This means an existing EtherCAT network controlled by a third-party EtherCAT master can be expanded using ICB-DAS slaves. ICB-DAS provides several types of EtherCAT I/O slaves. The ECAT 2000 series, represented in the module with the white housing. This is our standard I/O slave, and it meets the requirement of most EtherCAT application. The EC1 series, our EtherCAT plugin modules. The EC1 modules have to be connected directly into a prefabricated circuit board. The circuit board can be created by the customer themselves, or the customer has to commission an engineering company with the PC board design and production. So the advantage of this series is it simplifies the wiring process. Then the EC2 series, this series is ICB-DAS high-speed slave, support a cycle time of 100 microseconds. It comes with additional features required for some application. For example, screw lockable RJ45 connectors, external rotary switch for slave address setting. In most applications, the slave address is automatically set by the master. Some customers, although, prefer to set the slave address manually to prevent incorrect installation during the EtherCAT wiring work or during the replacement of faulty devices. In addition, FOE support is provided for updating the firmware if required via the master. And our fourth type is the expansion unit, the EP8000 series. It's basically combines several distributed slave stations into one compact unit to decrease the required cabinet size. The EtherCAT 2000 series is ICP-DA's standard EtherCAT I/O type, which meets the requirement of most EtherCAT applications and supports a cycle time of up to 0.5 milliseconds. A wide variety of I/O modules with different channel numbers are available. Modules with 4, 8, 6, and 32 channels are provided. ICP-DA provides up to 30 types of EtherCAT 2000 I/O slaves, such as digital modules, photo-isolated DI, relay contact, photo-MOS relay, open collector, and analog module for measuring voltage and current and temperature measurement, etc. The EtherCAT 2000 series offers an extreme wide of I/O spectrum to choose from, which meets the requirement of most EtherCAT-based automation application. The EC1 series is our plug-in solution for the EtherCAT network. The modules are designed to be plugged directly into a prefabricated circuit board or signal distribution board. The customer can develop the signal distribution board themselves or outsource the development to other companies or make use of ICP-DA's engineering service to develop and manufacture an application-specific board. ICP-DA provides the development of signal distribution board as an engineering service, allowing the customer to focus on their core competencies. The plug-in solution replaces the often time-consuming manual wiring processes. The figure on the left shows the conventional point-to-point wiring process needed for connecting remote EtherCAT I/O modules. Each I/O channel, each I/O point has to be wired one by one individually to an external device, such as switch, valve, sensor, or actuator. So external manual wiring of single wires is time-consuming and increases the risk of incorrect wiring. The right figure shows an assembly of the EC1 plug-in module with a customer-specific circuit board. So the electromechanical design allows the direct connection of the plug-in modules to a circuit board. This means the elaborate, extensive manual wiring of single wires, as indicated by the red circle, is replaced by a circuit board with integrated connectors. The circuit board distributed the I/O module signal via the integrated connectors to an external machine module. This solution is an efficient method for serial production with medium and high quantities. The wiring effort is reduced considerably. The risk of incorrect wiring is reduced to a minimum. In addition, it reduces the required cabinet spaces, thus optimizing the machine footprint. This slide shows, again, an assembly of plug-in modules, circuit board with integrated connectors of different types. So all types of connectors interfaces can be used for sending the I/O signals from the plug-in module via the circuit board and pre-assembled cable harness to an external module. So the combination of I/O modules, signal distribution board, pre-assembled cable makes the installation of the automation system very efficient. The EP800 series is our EtherCAT I/O expansion module. The trend in the industry is to increase the compactness of the machine plant and reduce the cabinet size. So the purpose of the EP800 expansion device is to combine several distributed slaves into one compact unit to reduce the required cabinet space. The EP800 is basically a compact multi-station solution. You can choose chassis with 1, 2, 3, 5, 9, up to 11 slots. Slots can be left empty. The empty slots can be used for future machine extension. And the benefits of the EP800 series is plug-in modules can be quickly and easily inserted and removed from the front of the rack. Plug-in modules are easily replaceable. If one plug-in module fails, it can be replaced with this while the system is running. So it supports hot plug. ICP just provides a variety of different plug-in modules for the EP800 series. The product range of the plug-in modules stretches from various DIO modules, analog I/O modules for current, voltage, temperature measurement, up to gateways and more complex modules such as stepper motor controller. Each plug-in module is an independent EtherCAT slave with its own address. The EP800 allows flexible module combination depending on the application's requirement. So all configuration is done via the EtherCAT master. No additional configuration tool is required to configure the plug-in modules. Next to our stepper controller series, EtherCAT stepper controllers solution consists of single-axis and multi-axis stepper drive. The multi-axis controller type simultaneously control up to 4 stepper motors. The main controller features it is a 2-phase bipolar stepper driver and is designed to open in an open loop. Depending on the controller type, a maximum motor coil current of 3.3 ampere per phase is supported. High microstep solution allows a smooth and precise motor operation. The controller comes with an integrated incremented encoder to determine the real motor position and DI channels for position latch and hardware limit stop switches. All EtherCAT operation modes are supported, which means motion control can be done with the real-time or non-real-time EtherCAT master. Currently, we have got 3 controller types in our portfolio. The supported motor control current depends on the controller type. The ECAT 2094DS is our newest controller type on the market and supports a current of 3.3 ampere, as well as it supports CIA for 2 defined motion profiles. We provide 2 and 3 channel encoder. Multiple counting modes are supported, such as clockwise, counterclockwise, pulse direction, AB phase, etc. Maximum count rate of 4 MHz supported. It has a built-in hardware latch, which can be used for homing and measurement purposes. The ECAT 2092 supports a multitude of position compare functionalities to meet the different requirements in the automation industry. It has got single compare, fixed distance compare. In addition, up to 200 compare positions can be directly stored in the module. EtherCAT gateways allows industrial equipment that does not support the EtherCAT communication protocol to smoothly exchange data with the EtherCAT master. ICP provides EtherCAT gateways for Modbus RTU, TCP, and CAN Open. The gateway acts either as a slave or as a master in the local network. The gateway allows the connection of just one module, like a Modbus or CAN Open module, or a network of Modbus or CAN Open slaves. ICP offers junction modules with 1, 2, 4, and 6 port branching. Junction has 3 purposes. It is being used to extend an existing network by extending its topology. By using a junction, a topology, all topologies variants can be implemented, like line, star, tree, daisy, etc. Its second usage is to avoid the network, to divide the network into smaller segments, to improve the network stability and prevent an entire system breakdown if one of the network system fails. So the top left figure shows an EtherCAT network with line and daisy chain topology. If one of the slaves breaks down, as shown in the picture on the top bottom left, then the EtherCAT master cannot access the slave following the faulty device. This means a total system breakdown. The top right figure shows the same network divided into 3 segments by using a junction. If one of the segments fails, then the slave of the other segments in the network can still be accessed. So the junction basically makes the system more fail-safe. In addition, makes error detection and troubleshooting easier. And third purpose of the junction is cable redundancy. Cable redundancy can be achieved by implementing a ring topology using a junction module. A ring topology basically enables multi-pass for the data transmission. In case a cable or connection failure, the EtherCAT frame automatically selects one of the alternate ring paths to access the slave in the network. Therefore, cable redundancy allows the network to remain available and avoid downtime in case of a single cable failure in the network. ICP does EtherCAT fiber converter basically converts copper signal into a fiber optical signal. The main application is to bridge larger distances between the slaves. Up to 25 kilometers is possible between slaves. In addition, it reduces the influence of electromagnetic interferences in an EtherCAT network to ensure stable operation in industrial environment with harsh electromagnetic disturbances. So this is the end of the EtherCAT slave series presentation. Again, it is important to note that all our EtherCAT products are developed and manufactured in-house. Both hardware, software are developed in-house. This allows us to flexible and within a short period of time adapt our EtherCAT products to an application-specific need of a customer. Now to the software development kit provided for our EtherCAT master and EtherCAT-based motion controllers. ICP-DAS provides extensive software tools and libraries for its EtherCAT master to assist the system integrator in setting up the EtherCAT network and implementing his application program. Our EtherCAT master workbench is called EtherCAT Utility. This software contains configuration and diagnostic function to speed up the construction of an EtherCAT network. In addition, this tool can take direct control of each slave and read its input and set its output data. It supports single and multi-axis motion testing, basic motion functions such as point-to-point motion and interpolation can be directly commanded using this utility. In addition, this utility contains graphs for tracking the path of the motors and for plotting the motor velocity and acceleration values over time. Further libraries for accessing the EtherCAT network and motion controls are provided. The libraries can be integrated into all standard Windows and Linux programming languages. Plenty of demo programs available, and no in-depth EtherCAT knowledge is required by using our libraries. The motion engine integrated into our EtherCAT master automatically detects, configures server-stepper drives, which meets the CIA 402 drive profile specification and operates the motor without tedious configuration. The table below lists the server drives that have been successfully tested together with our EtherCAT-based motion engine. All CIA 402 drive profiles are supported. Virtual access functionality are available, which means a server or stepper drive does not need to be online for the motion engine to generate a motion path. Most single and multi-axis motion commands are implemented according to PLC open-defined specification. This slide shows some basic motion control features supported by our controller, such as T and S curve acceleration, contouring, movement, change velocity on the fly and position on the fly, multi-axis, linear, circular, and helical movement, etc. Our EtherCAT programmable automation controller comes in two versions, the Windows-based controller and SoftPLC-based controller. The SoftPLC controller, the PLC application is to be written with ICP-DAS PLC integrated development environment called Win-GRAF Workbench, which I will be introducing in the following. Win-GRAF Workbench is a PLC programming software provided by ICP-DAS for programming our SoftPLC controller. It is a development environment for designing, programming, configuring, debugging, and maintaining machine applications. The 5 PLC programming languages, such as structured text, function block diagram, letter, etc., are all compliant with the IEC 61131 standard. The Win-GRAF Workbench development environment comes with plenty of tools for editing, configuring, monitoring, and debugging the PLC application program. Included are network configuration tools for setting up the EtherCAT master, the Modbus and server slaves, and for integrating the OPC UA server. As I already mentioned before, our programmable automation controller are all equipped with expansion slots to expand the local IOs. ICP-DAS offers a large portfolio of IO plugin modules. The Win-GRAF Workbench provides tools for configuring the local IO plugin modules, which is needed, for example, to set the engineering units for analog modules. The Win-GRAF platform comes with human-machine interface support for designing graphic control interfaces. Currently, 2 HMI versions are available: the E-Logger, which is ICB-DA's in-house developed HMI software, and Aveva Edge, formerly known as Indosoft. Both PLC and HMI runtime run concurrently, simultaneously on the same PLC platform. Several field bus communication protocols are supported by our soft PLCs, such as Modbus, TCP, RTU, ASCII, master and slave, EtherCAT communication for our EtherCAT-based motion controller, and in addition, Win-GRAF has a built-in OPC server that can transmit PLC data to remote OPC clients like HMI and Cloud Server. All 3 EtherCAT-based soft PLC types have an integrated motion controller. The motion control function blocks are implemented according to PLC open specifications. Most PLC open defined single-axis and multi-axis function blocks are available. Up to 32 server or stepper axes can be controlled synchronously. All drivers with CIA4 profiles are supported. Now, I often get the question from customers, what is the difference between an ICB-DA's PLC and a PLC like Codesys or Trinket? First of all 3 PLCs are software PLC types. Soft PLCs are designed to run on a standard industrial PC with a Windows or Linux OS with real-time OS extension. So traditional PLCs, such as Siemens, Allen Bradley, or Schneider, are hardware-based PLC. They are designed to directly run on a CPU or hard real-time operation system. A hard PLC is a closed system and its functionality cannot be flexibly extended. The advantage of a soft PLC like Win-GRAF over traditional PLC is soft PLC are more flexible for extension. For Industry 4.0, flexibility is a key component. So soft PLCs such as Win-GRAF are developed with Industry 4.0 in mind and can be flexibly expanded to support M2M and IoT functionality. In addition, because the runtime runs on the PLC, it does not just run the PC logic, but also various applications in parallel. So, for example, web server, HMI, OPC server all run parallel with the PLC application on the same Windows PC or Linux PC platform. In addition, soft PLCs uses vendor-independent programming languages. They use a standardized IEC 61131 programming language. Soft PLC are mainly used for decentralized I/O control, like EtherCAT or Profinet, controlling of EtherCAT or Profinet network, while traditional PLCs focuses on centralized I/O control. So the number of I/O points supported by soft PLCs are almost unlimited, while the number of I/O points of hard PLCs is limited by hardware and local I/O expansion boards. So soft PLC compared to hard PLCs have an ability to manage and store large amount of data because the PC memory size is considerably larger than that of a hard PLC. Next, I will show some application implemented by our customer using ICB-DA's EtherCAT products. This slide shows a couple of basic machine applications implemented using our EtherCAT products, like component pick and place, high precision, stationary, welding and gluing machines, quality control, monitoring of production system, and simulation system. An application recently implemented by our customer, a manufacturer of coating machines needed to upgrade a vacuum coating machine designed for coating solar photovoltaic panels with special thin films to increase the efficiency of the solar panels and for panel protection. To increase the efficiency of the machine, the customer decided to replace the traditional motion control with EtherCAT server drives to simplify the system, reduce the wiring costs, and increase the speed and accuracy of the coating process. The customer replaced the vacuum pump with a more efficient one to increase the coating quality. The new vacuum pump only communicates via Modbus RTU. Therefore, a gateway is necessary to enable the communication between the EtherCAT master and the vacuum pump. So the customer, after evaluating EtherCAT products from different vendors, the manufacturer opted for the master and the slave products from ICP-DAS. As the entire machine upgrade could be purely done by using ICP-DAS EtherCAT products such as master, I/O slaves, gateways, etc. Another factor which contributed to the customer's decision was the engineering service provided by ICP-DAS, which increased the implementation speed of the machine upgrade. For example, ICP-DAS provided some customized motion control functions which simplified the integration process. But in general, ICP-DAS is ready to add features and functionality to our products to meet the customer's application-specific needs. Cutting application in automation industry has been realized using our controller. For example, high-speed stationary cutting machines that processes the workpiece as it moves along the production line to increase the production output and efficiency. This type of application requires multi-axis coordinated motion control to synchronously move the cutting tool and the workpiece. Pick and place application, a manufacturer of conveyor system in Taiwan developed a mechanical multi-axis gantry pick and place system to transfer heavy workpieces from workstation to workstation with high precision and for a production plant. The gantry axes are mechanically connected, and therefore tight coordination, synchronization between the gantry axes is required to prevent any distortion in the mechanical structure. To the satisfaction of the manufacturer, the pick and place system was implemented with the EtherCAT-based motion controller ECAT M801 from ICP-DAS by using the gantry control function of our motion controller. The position deviation between the gantry axes could be kept within the system limits. Another field of application is the packing industry, for example, automatic wrapping of products while it's moving along the conveyor belt or filling of bottles, etc. Our EtherCAT products are also suitable for controlling multi-axis simulators. A company specializing in the development of simulators created a flight and a vehicle simulator for training students. The flight simulator are being used for preparing future pilots for realistic flight situations, and the driver simulator for training truck drivers in the truck driving school. Both simulators were implemented using a 6-axis hexapod structure. The company uses our PCI card to control the simulator's 6-axis hexapod, its position, tilt, vibration, etc. In addition, uses analog and digital slaves were used from ICP-DAS to measure the input and the of certain simulation-related sensors. Another application is the semiconductor industry. The semiconductor industry plays a major part or role in the Taiwanese industry. Several products have been in the semiconductor industry have been implemented with our ICP-DAS products. Precision machine control is critical for the IC industry, for example, in preventing IC defects during the production process, as well as maximizing IC processing throughputs. Precision is also required to place electrical components onto circuit boards. A customer, a developer of inspection system for IC components uses our EtherCAT solution to build an automated test plant for IC inspection and quality control. The plant consists of mainly 2 parts. The first part is the inspection machine, which transferred finished semiconductor components to the inspection site for electrical and performance testing. And the second part, the automatic sorting machine that removes IC components that failed the inspection test from the production line. The construction of the test facility is quite complex and requires 20 stepper motors to control the entire inspection and sorting process. The customer realized the project by using our real-time EtherCAT PCI master card in a compact industrial PC. The customer uses 5 sets of our 4-axis stepper controller to control 20 axes and precisely control each step in the inspection process. Another project implemented using our products, a well-known hard disk manufacturer is using our encoder slave to monitor the production process and to carry out quality control after each production and assembly step. For example, it's necessary to inspect each flash chip before the machine begins assembling the hard drive. As the assembly process progresses, a number of different steps are required, such as reading and writing stress tests, high temperature operation tests, etc. So our customer uses our compact 3-channel high-speed encoder counter slaves to control the inspection process and uses the encoder multi-position compare function to trigger the test operation. Using the ICP-DUS solution, you can build an entire machine automation and automation plant. ICP-DUS EtherCAT solution provides an efficient and effective way to control and monitor a production process or improve the production process of an existing plant. All EtherCAT products are developed and manufactured in-house. ICP-DUS is therefore able to flexibly implement any application-specific requirement requested by our customer. Thank you for your attention. Please do us a favor and scan the QR code and give us your feedback. We are now coming to the question and answer session and are open for the forum for questions.